Please welcome Erika with your talk.
Nice to see you here. I hope that you had something nice at lunch, but maybe not too nice, so you fall asleep. So I'm going to start by asking you a couple of questions. So how many of you use Rails today? Yeah. Trying to decide how harsh I'm going to be. No, just kidding. I like Rails. No. So how many of you knows Hanami or has worked with Hanami? Yeah, pretty many. That's nice. So today I'm going to talk about web development in Ruby at 84Codes, the company I work for. And I will start off by explaining what we do and how that affects our system architecture and our development principles. Then I will give you a short introduction to Sinatra, which is the web framework that we use, and also introduce Rails and Hanami, just to get everyone up to speed. At last, I will go through our web application setup and explain how we make do with Sinatra and other tools, but foremost what we can improve based on what I have learned from Rails and Hanami. Okay, but first, an introduction of me. My name is Erika, and I'm based in Stockholm. I usually go to the gym, swimming, running, skiing, or biking, and even more biking. But also, I work as a developer at 84Codes. And I have been doing that for almost 4 years now, but I only worked full-time for about 2 years, so be kind, please. And currently, I work in our observability team, which is responsible for monitoring of our systems, but also our customers' servers. And this means managing logs, metrics, alarms, and much more. But I'm also very interested in developer experience, and that's what brought me into this topic today. So enough about me, and let's dig into 84Codes. So 84Codes was founded 2012, and we are now around 40 employees, and around half of us are developers. 84Codes is foremost known for Cloud MQP, or Message Broker as a Service, and we maintain the largest fleet of RabbitMQ and LevinMQ servers worldwide, and it's consisting of like over 13,000 servers. I want to ask you one more question. So how many of you are familiar and have worked with RabbitMQ? More than I thought. That's nice. So RabbitMQ is one of the most used message brokers, and we have provided RabbitMQ as a service for quite some time now. LevinMQ is our own built message broker released in 2022. And LevinMQ as well as RabbitMQ follows the AMQP protocol, the Advanced Message Queuing Protocol. I'm going to explain shortly how a message broker works and what it's used for, because I think it's kind of important to understand how we develop web applications and why we do it in the way we do. So think about a system built of multiple services, let's say a web shop, where one service is responsible for the web shop content, one service is responsible for the cart and checkout, and one service is responsible for the payments. These services need to communicate with each other. And the message broker allows the services to do that asynchronously, and with the help of message queues. So let's say a customer of the web shop has added something to their shopping cart and goes to checkout. The checkout service, called the producer, sends a message to the message broker and can already then notify the customer that the payment is processing. The message broker puts the message in the correct queue defined by the sending service, the producer, and the consuming service, the payment service in this case, can then subscribe to the queues it is interested in and then consume the message once it has arrived in the queue. And now the consuming service can start to process the payment. When the payment is done, it can send a confirmation to another service responsible for notifying the customer about the payment. So this is a simplified explanation of what a message broker does. In reality, there's a bit more to it. And if you are interested in learning more, I can really recommend the CloudOnQP website, or check out our free RabbitMQ course at training.cloudownqp.com. So now we move on to how Ruby is used for codes, and also a bit about other languages we write in and what kind of projects we maintain. We have approximately 20 applications written in Ruby, and these are our main applications, but we also have around 15 applications written in other languages. And these are for like notifications, metrics, logs, alarms, integrations, webhooks, and yeah. Some of the other languages we code in are JavaScript, Clojure, and Crystal. Crystal is a language with syntax very similar to Ruby, but is faster and more efficient due to being a compiled language built on an LLVM. And yeah, Crystal is also a typed language, so if you're leaning towards typing in the Ruby discussions, maybe you should check out Crystal. We use Crystal for applications where efficiency is important. And we, for example, use it in our open source message broker LabinMQ. So we also maintain some open source software like RabbitMQ. We also have some proxy servers, AMQP clients, a Terraform provider, and some more. So another reason for using all of these languages is that the goal of 84Codes has always been to allow developers to do what they think is fun. So yes, our main language is Ruby, but you are always encouraged to try out new languages when you want to or when it fits the use case. So this is a simplified version of the architecture of the main part of the CloudOnQP system. We have a main service which handles interaction with the customers. This service sends messages through LabinMQ to the job service. The job service handles communication with our cloud providers, AWS, Azure, Google Cloud, and DigitalOcean. And yeah, to manage the servers provided by them. It also installs and configures RabbitMQ and LabinMQ and manages everything else regarding the actual servers. Then we have a listener service, which makes sure that things gets updated in the database. And we have other services subscribing to messages in LabinMQ as well. And this is one of the main reasons why using a message broker is great for us, because then other services can listen to the queues they're interested in and get the messages they want to do their job. And this also allows us to use services in different type of languages and so on without any hassle. So our main web applications are built in Ruby and with Sinatra. So why is that? So when 84Codes were founded, Rails were not as widely used as today. But the reason for choosing Sinatra was mostly due to wanting to start small, and the service was built as API only from start, which didn't really match Rails back then, being more for full-fledged web applications. Only later Rails added their API only option, making it easier to use only for web or for API applications. So Sinatra matched our criteria better, and since then we have just continued to work with Sinatra and are now kind of stuck with it. We have started to look into alternatives, and this is why we have investigated Rails and Hanami to find out what we miss by not using another framework. And the motive behind looking into other alternatives is to foremost to get more support from the framework, but also to make it easier to hire new developers with the good former experience in the framework we use. So, what is Sinatra? It's a web framework for Ruby. It provides routing, request handling, and view management. Sinatra requires a rack-compatible web server. We use Puma. And I will talk more about Sinatra and our web stack, but first I want to very shortly introduce the two other frameworks. Let's start with Rails, which is by far the most used Ruby web framework today, as you saw. And Rails is, according to the website, optimized for happiness. And yes, probably for most, if you like it the Rails way. And with that said, Rails is a very opinionated framework, and the philosophy is convention over configuration. So Rails was built to make web development easier and faster by allowing developers to write a lot less boilerplate code. So as long as you follow the Rails conventions, it's very easy to set up a Rails application. But this also means that things happen very magically, and it can be a bit confusing to understand how it works. It just does. Hanami, also a web framework, which has its first stable release more than 10 years after Rails, which might be why it's much less used than Rails. It was built to be a very lightweight, modular, and performant framework compared to Rails' more monstrous approach. Okay, back to Sinatra and our web stack. So one of the things we miss in Sinatra is that it doesn't force a specific structure. I think the only thing Sinatra expects by default is that views are placed in a views folder, but that path can be changed as well, leaving everything up to you. And if you create an application and have no set architecture from the beginning, it may become a real mess. Here is how our architecture looks like. It's a bit inspired by Rails and the model view controller pattern, with the controllers receiving requests and forwarding them to correct actions. And the actions interacts with the model and updates the views. But at the layer between the database and the controller is where it has gone a bit wrong for us due to not having a forced structure. In some places, we have controllers communicating directly with the database. We have controllers communicating with a model, which then communicates with the database. And some controllers communicate with a service, which then communicates with a model or directly with the database. And this is an issue because it creates confusions and misunderstandings when it differs in the code everywhere, and the lead time for developing something grows. We are trying to unify this by always having the controller communicating with the service, then a model, and then the database. Rails, on the other hand, kind of forces this MVC structure, but Rails is also pretty flexible. And it's not unusual to find Rails applications with more abstractions. An example, like we try to go against, like having a service or something, a middle step between the controllers and models. And it might be because since Rails application often are monoliths, it can grow really complex without those abstractions. So Hanami is also based on the MVC pattern, but with a lot more abstractions. The controllers are non-existent, and requests are processed directly by the actions. Each action is a self-contained class, and by default renders its equivalent view. Views are abstracted into parts and templates. Parts includes view logic, and templates are the actual HTML structure. The template engine used is ERB by default in Hanami and also in Rails, I believe, but it's configurable. We use Haml, for example. And the model part of an Hanami application are abstracted into repositories, relations, and entities. And I think the main part for this is that repository objects puts abstractions over the ORMs so that the actions can communicate with ordinary Ruby objects. I like the idea of more abstractions, but I don't really have enough knowledge to have a opinion about it, strict opinion about it. So another thing used in Rails and Hanami that forces you to follow a specific structure is zeitwerk. So if the application follows the convention that zeitwerk expects, you don't have to add requires or require relatives, which is amazing. And now you're sitting and thinking, oh, that's so 2019. For me, it's pretty new. So this is an actual example from our code base. And I promise not every file looks this horrible. But yeah, this would be so satisfying to be able to clean it up. Another nice thing with zeitwerk is that it provides autoloading of your classes and modules when files are changing in the application. This gives a more pleasant developer environment where you don't have to restart your app when you do changes and try them out. And for production, it allows you to eager load the application so that the user experience doesn't become slow due to that code hasn't been loaded yet. In our development environment, we use rerun instead. Rerun is a Ruby gem that can restart any process when files changes. In our case, it restarts Puma. This approach will probably be a bit slower than just reloading classes and modules like zeitwerk does, but it kind of works for us. Okay, now I'm going to talk about something that Sinatra actually provides, routing. So this is an example of how routing can be done with Sinatra. The main routes is defined in the config route class, and then each controller includes its own route. But this structure makes it a bit hard to get an overview of all the endpoints the application has, since you have to go through all the controllers. Rails instead have all routes configured in a routes file, which makes it easy to get an overview of the endpoints. The resources here creates routes for get, post, put, delete automatically, but you can also set tags which ones you actually want. And the only negative I see with this is that you might forget to remove routes that you don't use, which can give you some errors in the application. And for Sinatra, you have to create them by yourself, so you know that those are there. Another nice feature in both Rails and Hanami is the command to list all the routes in the application, and which you also see which controller and action it points to, making it very easy to get an overview of the application endpoints quickly. So that was almost everything that Sinatra provides, and since Sinatra doesn't provide an ORM for database integration, we use SQL. SQL is a well-used and maintained ORM, and it fits our purpose pretty well, and we are happy about it. The maintainer, Jeremy Evans, makes a really great job of maintaining SQL. Issues are never open for long, and the documentation is comprehensive. Only issue comes when trying to use GitHub Copilot. It always shows active record examples. And when I'm trying to Google, every solution I found on Stack Overflow is active record. Okay, so this is models in SQL and active record, which does basically the same thing. In SQL, you have to load the plugins, since not all are loaded by default. To define relations in SQL, you use the ordinary one-to-many, many-to-one relations and such, instead of active records, all named relations like has many and belongs to, and so on. The association dependencies is also a bit different, and yeah, you can see that active record in total can do a lot less lines of code. Pretty fascinating. So Hanami is also currently shipped without an ORM, but seems like that might change pretty soon. But right now the documentation refers to ROM-RB, which actually also uses SQL under the hood. So that's pretty interesting. Another thing that Active Record does is that it creates a lot of rake tasks for database operations like migrations and such. But I mean, I'm not even sure I know what all this does. Does you? We have instead implemented our own migrations task, which takes versions as an argument, and if a version isn't passed, it will migrate to latest and so on. We have also implemented a seeds task and an annotations task. And annotations is in SQL, and this is a SQL thing, I think. And it's pretty nice. In the end of all the model files, SQL can add the table schema, making it very easy to understand what you deal with in a model. So for this, we have also added a rake task, which creates a database, run migrations, and then adds this schema to the models. Since we are talking about nice default tasks, let's look into how Rails and Hanami provides easy commands to create apps and generate a lot of boilerplate code for you. So setting up a new app, you can do with a new command in both Rails and Hanami. You can also add some flags to share some config, like if you don't want to use SQLite, you can set to Postgres like we use. And in Rails, you get a lot of components included, so you might want to skip some of those, but that's pretty easy as long as you know what you want to skip. For example, I would skip active job since we use microservices, and we usually do asynchronous task in another service, and we use 11MQ to handle the communication. I would also skip active storage because we don't really have a use case for it. The data that we either store in our databases or we store directly to S3 from our servers. I would also skip Action Cable, which is WebSocket support. We don't use WebSockets in Ruby apps at the moment. And Action Mailer is not needed for us since we have written our own mailer project. And I would also skip Action Mailbox. We don't read emails from code. There are also some other options in Rails. You can create an app with the minimal flag or with the API flag, create an app without views. And for Hanami, since Hanami doesn't overload you with the components, it's not that many flags that you can set, but you can use the skip assets, which is relevant when you want to create an API app. In Rails, you can also generate a controller, model, and much more, and the same for Hanami, but only actions, parts, and views, since Hanami doesn't come with a default ORM. In Rails, you can also use Scaffold, which creates a controller, model, view, and routes, and also some test files. And you get some code for free with the Scaffold command, but you still need to rewrite your models anyways. And in Sinatra, you mostly end up copy-paste stuff, but I mean, all solutions are good if they work, right? Another command that comes out of the box in Rails and Hanami is the possibility to interact with your application with the command line use IRB. Hanami also offers this feature, but Hanami makes it possible to also use pry. But we have implemented this feature for ourselves, and only with a few rows of code. And as a last part, I want to talk about test frameworks. We use mini-tests, but with spec style. So this style is a bit more similar to RSpec, which I'm also going to talk about very soon. With the spec style, the tests are organized in a more behavioral and context manner. So describe blocks are used to group related tests and usually describes a behavior or a class or a method. And it blocks specifies a specific test. And these blocks makes the tests a bit more readable and descriptive, and that's the goal of them. When verifying conditions, it can be done with assertions or refute, just like with the assertion style of mini-test, but the usual way is to use expectation syntax, like in this example. And this means using variants of the expectation methods must be or won't be, and so on, since those also are seen as more descriptive and readable and aligns with the goal of the spec style. Rails has the component active support test case, which uses mini-test with assertion style. But you can, of course, use another test framework if you rather want that. Mini-test assertion style is class-based, and tests are organized within subclasses of mini-test tests, and individual tests are defined as methods. To verify conditions, different types of assertions or refutes are used. Furthermore, Rails, of course, applies some magic in the test as well, like the cluster's URL variable, and so on. When creating an Hanami app, RSpec is instead used by default. And RSpec is a test framework with focus on behavior-driven development, so just more similar to mini-test spec style as well. These tests are also written with describe and context blocks and it blocks. And to verify an object, you use expects, and then a verifier like equal, be, or include. So that was it for the comparison. So what's the result of all this investigation? I would say that the biggest reason for not continuing using Sinatra would be because of the not so active and small community. We have to put in hours to help maintain it. But it would also probably take much resources turning our applications into Rails or Hanami apps. But we will probably make some, try it out and see if we should go that way. But we have implemented most of what we think is needed with, just by yourselves or with the help of GEMS. So the different services like Mailer, this Mailer service, rake tasks for migrations and IRB. But one thing I really would like to experiment with is zeitwerk. That would be really nice to see if we can implement in our apps today. So that was it for me today. I have learned so much when writing this talk, so I really appreciate that you have listened and hope that you have learned something as well. Thanks.
Thank you.